Okay, I said raise our hand. Curtis. An equilateral triangle. And what does that mean? Fantastic. Take a point. And as Jarvis screamed at us, it's an isosceles. What does isosceles mean?
Two sides.
Two sides are congruent. All right, what about angles? What do we know about angle measure? There is a right triangle, and what do one of the angles have to be for it to be a right triangle? 90. Good. Take a point if you've answered. All right. What about, there's another, scaling. What does scaling mean? No sides are congruent. Good. Take a point. What about angle measures? What do you know? You don't know my mom at all. She's at the doctor right now, so shouldn't know her at all. Yep.
I'm heartless.
You don't care that my mom's at the doctor for breast cancer?
I love you.
Thanks. Appreciate that.
I love you.
I do care about that.
All right, so we're going to talk about triangles by angles. There is acute and obtuse and right.
Is that ugly?
Acute. Be positive.
If only. I'm going to have to change groups again already because Ravenclaw's on my nerves. Or just start taking away points. We could do that. All right, so if every angle of a triangle measures less than 90 degrees, it is an acute triangle. And we're going to draw an example. Oh my goodness. You might need a straight edge today, just to let y'all know. So there are rulers in the third drawer and there are protractors in the second. So I would get those out. A ruler or a protractor, some kind of straight edge. Let's go, let's go. They're either in the second or third drawer. Alright, so in acute, they all must be less than 90. So draw a triangle where they're all less than 90. And we're going to call this 32 degrees. We're going to call this 68 degrees. And what must that other angle measure be?
30, 90, 200, 80.
What? 32 plus 68, you got 100?
90.
No, you're right, baby. I'm just making sure I'm understanding what you're saying.
Oh, yeah.
Okay, and then you did 180 minus 100?
Yeah.
And you got 80?
Yeah.
Good, take a point.
I was like, you said I was wrong. Okay.
Alright, so where did she get 80 degrees from? Or how did she get that?
Okay, so 68 plus 32.
No, I want you to tell me, I don't need you to explain it again. I want you to tell me how she got it. Like, why did she use 180?
Because it's a straight line, because
Yes.
32.
No, baby.
All
Curtis,
triangles are 80.
Because the sum of all triangles is 180 degrees. Good. Should we maybe write that down somewhere?
Yes.
Okay. The sum of angles in a triangle is 180.
How?
Did you say how?
How?
Oh, okay. Alright, so if the triangle contains a 90-degree angle, what kind of triangle is it?
Right.
It's a right triangle. And we're going to draw an example. Alright, so my straight edge is going to be a note card.
You want this protractor?
No, I'm okay. Thank you. Don't even know anymore. Alright, and why did I put that little box in my triangle?
Because the sum of ours is 90 degrees.
Yes, great job. Take a point.
Are we smart yet?
I kind of tried to.
No, I don't know if you really want me to answer that question.
I don't. I thought you were really smart. You just act dumb.
So what would the other two angles have to, or could they be?
Maybe it could be 60 and 20.
It could be
I mean,
45. So if this is 45 degrees, what does this have to be?
45.
45 degrees.
90 plus 45 will put a 5 equals
Yes.
Math.
Math. Look at us go. Alright, so if the triangle contains one angle that measures more than 90 degrees, it is a...
Scaling.
This should have an and. This should have an N on it. Obtuse triangle. And we're going to draw an example of one of those. Now, it has to be more than 90. So it can look like this. I would like to, though.
We'll do a club together.
Sure. What kind of club you want to do?
But like, if we could think of an idea, I would love to do it.
Alright, so I want this degree to be 122 degrees.
Go for it.
And I want this one to be 38 degrees. So if this is 122 and this is 38, what does this angle have to be? Let's let everybody process for a moment before we start screaming things.
It has to be 30.
I don't know what that one angle.
I don't understand what y'all don't understand about process.
That's 62.
Process means think. This says 122, this says 38.
20.
Why?
Because 122 plus 1 plus 38.
Has to be 20.
Yeah, 20.
Okay. I just wanted us to breathe and process and not scream at me, but we still haven't learned that concept.
I say 20.
Alright. Next section. Can a right triangle be isosceles?
No. No.
What does isosceles mean?
2D personas.
So you don't think that it can be... let's come back to that. I'm going to prove you wrong. I'm going to prove you wrong. Alright, let's come down here. Alright, so if each of the three sides of a triangle are equal and the three angles measure 60 degrees, so this is very important. The three sides are equal and the three angles measure 60 degrees. What kind of triangle do you think that is? An equilateral triangle. Equilateral. Please spell it correctly since it's spelled correctly on the board.
Oh.
Like one day you're going to have to go out to the workforce and be able to spell stuff right. Let's practice it now.
Well, I'm going to have one on
I don't know how to read.
Alright, so if a triangle has at least two sides of the same length and two angles of the same measure, the triangle is an isosceles.
Isosceles.
I don't even know how to feel about this nonsense that he's saying over there.
Isosceles. That's a prime. Why you looking at me like
Can't imagine why. Alright, so if a triangle has three sides that are all different lengths and all the angles are different, it is a scalene, not scalene. A scalene triangle. Okay, now, knowing what we now know, that if it has three sides congruent and three congruent angles, it's equilateral. If it has two sides congruent and two angles congruent, it's isosceles. And three sides not congruent, three angles not congruent, it's scalene. Let's go answer our questions. Can a right triangle be isosceles? Yes, we just did that up here. We have a 45-degree angle and a 45-degree angle. And the definition of isosceles means that two angles are congruent. So if these two angles are congruent, that means these two sides are congruent. Put a little tick mark right there to show congruency. Okay, let's say it one more time.
Is it the angles that are congruent or the lengths?
Both. So the definition of isosceles is that two sides of the same length, therefore two angles have the same measure. Right? So these two angles have the same measure. Therefore, these two sides have the same measure. Boom. So, can a right triangle be isosceles? Yes. Can it be scaling?
No.
Are you sure?
Yes,
Oh, really?
I could have 30 right here and 60 right here, right? And then all of my angles are different measures. Therefore, all of my sides are different measures. What if I had 22 right here? What would I have to have over here? 68. Would they all be different? Okay, so yes.
Okay, she just threw down theirs.
Like, I don't know why we're confused when I'm proving it to you.
I'm alright.
Alright, can an obtuse triangle be isosceles? Well, if we said that this angle measure was 122, right?
Yes.
So the leftover angle measure would have to be, what, 68? Nope, 58? You could divide that in half and get these two angles. So if you have the other two angle measures the same, the sides would have to be the same. So therefore, could it be isosceles?
yes.
Yes. Could it also be scalene, like this one up here?
Maybe.
I don't know how else to explain it. Alright, can an equilateral triangle be isosceles?
No.
Yes.
No.
Baby, the definition of isosceles has at least two sides. Therefore, could it have three? Yes, it could have three. At least two means it could also have three. Could an equilateral triangle be scaling?
No.
No, because the definition of equilateral is that all sides are congruent. Are we ready to do some examples? Brace yourselves, children. Winter is coming.
Stop.
Are we ready?
Isn't that like Game of Thrones?
Yes.
From Game of Thrones.
I just said that.
You're talking about Let It Go.
Alright, let's turn it over to page 24B. Let's work out some examples. Yay!
Who's ready?
Alright, so I want you to write 24B, and then I want you to write examples, and I really want Ravenclaw to stop talking. It is. Everybody ready?
Yes.
Hold up.
Let's get breakfast. So I'm like dying here. Let's get breakfast. So I'm dying here.
Alright, example 1. Classify each triangle. And what are the 3 ways that we can classify triangles? If we're going to do it by angles. By their angles. So it could be acute, obtuse, or right. Or equiangular. What does equiangular mean? Equal angles. Take a point. So acute, obtuse, right, equiangular. EQUIANGULAR.
You got the sheet with copies on it.
For that other thing?
Whether you need it.
Yeah, I forgot to make my examples this morning. So we're just going to practice doing. 25. Thank you. Alright, so I want you to use your straight edge. Because we're drawing triangles and I want it to be perfect. And I want you to draw this line. And then I want you to draw this line. And then I want you to draw this line. And then I want you to draw this line. 4 lines. I'm sorry, are you not entertained? I need my other pen for a moment. Alright, does everybody have their triangle drawn? Okay, guys. Like, we're just drawing a triangle. Come on.
Yeah, but you said the yarn.
So it shouldn't take that long.
Practice to make it perfect.
It doesn't. Alright, I want you to label this 60 degrees. 60 degrees. 60 degrees. This is 30 degrees. This is 120 degrees. 30 degrees. Seriously. Seriously, just look at the board. It's crazy how that helps things.
It's kind of blue. You know, I have on my glasses.
You need some more black.
No, the
You need some
color.
more black.
Sunrise. You stay in my color.
Are we ready?
Yes.
Okay.
We are.
We're fine. He's just a little stuck.
Okay, so angle A, or I'm sorry, triangle ABD. ABD. Would that be acute, obtuse, right, or equiangular?
Equiangular.
Equiangular, why?
Because all of them are equal.
Fantastic.
I did that.
Alright, what about triangle BDC? Obtuse. Because one of those is more than 90. Which angle is more than 90?
120.
Which is angle
D.
D. Or BDC if you wanted to be real specific. Alright, and triangle ABC. The whole thing, baby cakes. The whole thing.
That's so cute.
Q.
It is not. What is the measure of 60 plus 30? 90. So what is it? It's a right.
Isosceles.
Okay, children. What I'm asking you for is ABC. This entire big giant triangle. So ABC is all of this, which means that you would have to add these two angles together to get that whole angle. And so, okay, thank you so much for catching on. All right, are we ready to classify by sides?
Yes.
Does anybody have any questions about angles? Yes, ma'am.
Okay, so the equal whatever that is,
Equiangular.
how did you do that?
Because ABD is this one right here, and all of the angles are 60 degrees. Yes.
C, why did you name the whole thing 90 just for those two?
Because if one angle is 90 degrees, it is a right triangle.
Just one person? No, that's okay. I'm gonna slow this.
Okay. All right, let's do it by sides. Are you guys ready?
Yes.
Example 2. Classify each triangle by sides. No, I'm in the middle of my paper. And what are the 3 ways we classify by sides? Flip back over.
Scaling, isosceles.
Isosceles, beliefs, and equality.
Yeah.
All right, scaling, isosceles, equilateral. And what does it mean if they are scaling?
No sides are equal.
What does it mean if they are isosceles?
At least two sides are equal.
And what does it mean if they are equilateral? All right, here's our first triangle. Use your straight edge. It doesn't have to be super perfect, but at least make your lines straight. What would A be?
Isosceles.
Isosceles, because it has 2 tick marks. Those 2 sides are congruent. That's what the tick marks mean. So it is isosceles. My voice is trying to go out. Alright, for B. What would this be?
Scaling.
Why would that be scaling?
None of the sides are equal.
None of the sides are equal. So that's scaling. Alright, and you could do equilateral, right?
Yes.
Like it would have 3 tickies. Alright, let's talk about homework.
Who started?
Me.
This raspberry cake, but now
Sweet Jesus in heaven, son.
You need to take a,
Don't talk to no one.
you need to
Ready
take
to
a
talk. Stay
writing.
focused. Okay?
Okay, homework.
Erase them.
Find X and the measures of the unknown sides. This is going to be super easy. Alright, problem number 1, or A, looks like this. Alright, and if I put little tickies right here and right here, what does that mean?
Sides are congruent.
The sides are congruent, same measure, good. This is 17. This is 3x minus 4. And this is 2x plus 7. And this is triangle L, M, N. Una más. Alright, if I put tickies on all of those, what does that mean?
All the sides are equal.
All the sides are equal, and it's an equilateral triangle. So what would you do with these values?
Add them.
Set them equal to each other. That's it. Just take 2 and set them equal to each other.
this raspberry on the floor, blue sugar, give me that on your face.
Yes, pumpkin. So on A, what would you do with those 2 values? Set them equal to each other. Guys, we're not adding anything. We don't have angles yet. We just set those equal to each other. Now, why would we set those equal to each other? Because they're congruent. Alright, on B, what would we do? Now, would we set all 3 equal or just take 2 of them?
Take 2.
Just take 2 of them.
All
So, do you have time right now to do your homework? Yes, you do. Do your homework. Especially if you need to ask questions.